Now let us see how to evaluate the integrals of the type as shown here. The first is integral of a sin x plus b cos x upon c sin x plus d cos x, and the second type is a e raised to x plus b upon c e raised to x plus d. Now here a, b, c and d are some constants that will be given. Now there is a same procedure to solve both of these types of integrals, and that procedure is we have to express the numerator as a into derivative of denominator plus b into the denominator itself. Now here just note that a and b in uppercase are some unknown constants that we have to find out, and based on that, once we are able to write the numerator as shown here, we will separate the terms and then the integral becomes easy to evaluate. Now let's see one question based on this type. Evaluate integral of 5 sin x plus 5 cos x upon sin x minus 3 cos x. So here we write the numerator first, that is we have to express 5 sin x plus 5 cos x as a into derivative of the denominator. Now for the denominator sin x minus 3 cos x, the derivative will be cos x plus 3 sin x, right, plus b into the denominator itself, that is we write sin x minus 3 cos x, right. So now collecting the sine terms, we have 3a plus b times sin x, and collecting the cos terms, we have a minus 3b cos x. So that means the numerator is equal to the expression that we have got here. So therefore, comparing the coefficients, the coefficient of sin x must be same on both sides, and similarly coefficient of cos x also must be same. So equating the coefficients of sin x, we get 3a plus b is equal to 5, and similarly a minus 3b is also equal to 5, and we have to solve these two equations simultaneously, and we will get the value of a as 2 and the value of b as minus 1. So what it means is we can rewrite the integral as integral of, now in case of the numerator, what we have to do is we have to write the numerator in the form that we had obtained. So a is 2 into cos x plus 3 sin x minus b is minus 1, so we wrote minus, and next we have sin x minus 3 cos x, which is nothing but the denominator itself, right. So whole divided by sin x minus 3 cos x. So that means if we break the first part, we see that 2 is constant, so that will come out, and now the numerator, which is cos x plus 3 sin x, is the denominator's derivative, that is derivative of sin x minus 3 cos x. So therefore the integral will be log of sin x minus 3 cos x, because if we have the integral of the form f dash of x upon f of x, that is a log of f of x, and minus, when we break the fraction, the second part will be nothing but minus 1, because the denominator term will get cancelled, and hence the integral of minus 1 is nothing but minus x. So therefore we have minus x and plus c at the end. So therefore this is the answer. Now the same procedure applies even if we have the integral of the other form, that is involving the exponential term e raised to x. There is exactly the same procedure.